In our own solar system, everything follows a strict cosmic dance. From Mercury to Neptune, the traffic flows in one direction. Earth, Mars, and the mighty Jupiter all orbit the Sun in the same direction that the star itself rotates. It's the rule of law in our neighborhood. But if you travel 1,300 light-years away, deep into the constellation of Scorpius, you'll find a world that breaks every rule we thought we knew.
Behind every moment lies a scientific wonder. I'm Kale, and welcome to SciCurious, where curiosity meets science.
Meet WASP-17b. Discovered in 2009, this planet immediately shocked astronomers and challenged our understanding of planetary formation. It was the first planet ever discovered with a retrograde orbit, meaning it moves in the completely opposite direction to its star's rotation. Imagine a car driving at high speed down a one-way highway, but in the wrong direction. That is WASP-17b, but its backward orbit is just the beginning of the mystery. Astronomers call it a puffy planet. It is an anomaly of physics. It has twice the radius of Jupiter, but only half the mass. Its density is so low, it's comparable to expanded polystyrene. If you could find a bathtub big enough, this massive planet would float like a beach ball. Why is it so bloated? The answer lies in the intense heat. WASP-17b orbits incredibly close to its host star, completing a full year in just 3.7 Earth days. This proximity, combined with its eccentric backward orbit, creates massive tidal forces that knead the planet's core, inflating its atmosphere like a hot air balloon. Recently, the James Webb Space Telescope turned its golden eye toward this giant. What it found in the atmosphere was groundbreaking. For the first time, scientists detected pure quartz crystals in the high-altitude clouds of an exoplanet. Imagine a world where the clouds aren't made of water vapor, but of tiny, shimmering shards of silica, the same material found in sand and glass on Earth. But you wouldn't want to visit. The winds whip these crystals around at thousands of miles per hour in an atmosphere hot enough to melt silver. Alongside the quartz, Webb detected water vapor, carbon dioxide, and sodium. It is a complex, chaotic chemical soup cooking in the vacuum of space. But the biggest question remains: how did it end up going the wrong way? Physics tells us planets form from a spinning disk of dust. Just like a figure skater spinning, the conservation of angular momentum means everything should spin in the same direction. WASP-17b defies this. This suggests a violent history. It wasn't born this way, it was forced. One theory is planetary pinball. In the chaos of the early system, WASP-17b may have had a close encounter with another sibling planet. The gravity of that encounter could have slingshot it into a wild, highly elliptical orbit, scattering its sibling into the dark. Or perhaps it was the Kozai Mechanism, a distant, unseen companion star pulling on the planet over millions of years. Slowly, painfully, tilting its orbit degree by degree until the planet literally flipped over its own star. WASP-17b isn't alone. It belongs to a class of planets called hot Jupiters, gas giants that orbit dangerously close to their stars. We used to think they were impossible, but we now know they migrate inward, destroying anything in their path. But among them, WASP-17b stands out. The puffy planet, the wrong-way world, the marshmallow giant. Studying it helps us understand the extremes of the universe. It tells us that our orderly, peaceful solar system might actually be the exception, not the rule. In the grand tapestry of the cosmos, chaos seems to be the new normal. Violent pasts, flipped orbits, and rains of crystal glass. Standing on a cloud top in WASP-17b, you would watch the star rise in the west and set in the east, amidst a storm of quartz. It forces us to ask, what other rule-breaking monsters are hiding in the dark, waiting for the Webb telescope to find them? Thanks for joining this journey to the edge of physics. Stay curious and keep looking up.
Science is everywhere if you just know where to look. Thanks for watching SciCurious. Until next time.